Before we begin working with operations, let's go ahead and focus on the classification of real numbers. Now, if you've taken math before, you will have seen some of these previously. For instance, in Math 1, we focused on whole numbers and positive rational numbers. Let's begin with the first set. Natural numbers are also called counting numbers. And if you can remember being a child or having a child and teaching them to count, you always started with 1. And they just counted 1, 2, 3, and so on. These are considered natural numbers. Now, the next set includes natural numbers, but it also adds 0. If you remember Module 1 in Math 1, we focused on our operations with whole numbers, and they were positive numbers, including 0. The next set includes these two sets, but it also includes negative numbers. So these are the opposites of the positive whole numbers. We'll be focusing a lot of our attention on integers this quarter. The next group includes all of these that we've already talked about, but they also include negative rational numbers. Unfortunately, this picture doesn't show a negative rational number, but it could just easily be negative 5/3 or negative 0.63 or negative 0.012 with a repeating line over it. With integers, we will also focus on rational numbers. So I know last quarter we focused on fractions and decimals and ratios. If you're still feeling like you need a little more work on that, you're in luck because we will focus our attention on this set. The last type of real number that we'll look at this quarter are called irrational numbers. And these are numbers that when we translate them into a decimal approximate, we find that the decimal it continues on forever, and it doesn't have a repeating pattern. Pi is probably the most common irrational number. As a decimal, we would round it to 3.14, but that's a number that's just going to keep going without any repeating pattern. Pi is also going to be used when we focus on circles or spheres or maybe cones. And we'll talk a little bit about some of those types of formulas this quarter. Another irrational number that's not listed here would be the square root of 2. If you are in construction or have done some geometry using the 45-45-90 triangle, then you will have heard of the square root of 2. And that is the hypotenuse of that right triangle, and that is equivalent to 1.414, and so on. And so, those are just a few examples of irrational numbers.